and they should turn out to be a straight line based on, you know, what the functions are. And you're going to see the difference between, you know, the straight line graphs and stuff like that when we do the class on Saturday when we continue. But so far, you've been doing, you know, these linear graphs. You've been doing these linear graphs. And we've looked at the equation of the line. Right, which was y equals to m x plus c. So we did equation of the line. We also looked at the midpoints. Midpoint, I think I write that wrong. So we looked at the midpoint. What else did we look at? The distance between two
The
points.
distance, yes. Stop.
Distance between 2 points. And what else did we do? That's it. Coordinate of the midpoint, distance between 2 points, and the equation of the line stuff, right? That's all we did. All right, so we're going to move forward today. And we're going to be looking at same straight line graphs, but we're going to be looking at now if you have two lines on the graph. So let's say I draw, I'm wanting to draw this straight. So let me do my best. Ugh. All right. All right, this can work. All right. So let us say we have, let's say we have this, this straight line, this Cartesian plane, and we are going to plot a line on it, right? Let's say we plot a, need this line to be straight as well. Let's say we plot, let's say we plot a line on it, right? This is a line we're going to be concerning ourselves with. This line, we're going to name it AB, right? So let's say we have this line AB on our axis, and we on our Cartesian plane, and we also have an additional line that we're going to, I'm going to draw it. Just assume that it is straight, right? I'm going to call this line CD. What did I use? Blue. So I'm going to call this line CD. Now, because AB, line AB and CD are running in the same direction, right? So they're running in the same direction. Or probably more, boy, this handwriting awful, but probably more accurately, they are slanted in the same direction. So they're slanted in the same direction, and they're slanted to the same degree. And by to the same degree, I mean they have the same amount of slant, right? The only thing is that it's not on top of each other. There are some distance apart, right? There, if you should, if I could shade it in between, we could shade some distance between A and AB and CD, yes? But it doesn't matter if CD was all the way over here or it was down here, as long as these two things hold true, it is slanted in the same direction, and it is also slanted the same amount to the same degree, we say that AB and CD are parallel lines, right? So we call AB and CD parallel lines. Everybody follow me so far?
Yes, ma'am.
So
Yes,
AB
ma'am.
and CD are parallel. All right. Now, why is this important and why are we spending time on it, right? Now, when you plot two lines on a graph, and if it is that they are parallel, then there is one important piece of information that you can derive from just the fact that they are parallel. Because they are parallel, and meaning that they slant in the same direction, and also that they slant in the same, to the same degree, there's one important feature: their gradients are the same, right? So when you write the equation of the line for AB, which is y equal mx plus c, and one for CD, which is y equal mx plus c, the y's and the m's can be very different. The c will be different, but the m will be the same. The gradient will be the same. Everybody following me? And we can see that from a practical perspective, right? They slant the same way because they're parallel. That's what defines lines that are parallel. They're running the same direction and they're slanted to the same amount, to the same degree, however you want to express it. And remember that when we spoke about the gradients, our last class, we emphasized that the gradient measures the slant or the slope of the line, right? And now we're hearing that for parallel lines, they're going to slant or slope the same amount, the same degree, the same way. So it follows then that the gradients would be equal. So the gradient of AB, let me just write this properly. So what it would mean is that the gradient of AB, so I put in gradient as M, of line AB is going to be the same as the gradient of line CD. Follow? That makes any sense to you?
Yes, ma'am.
Makes sense? All right.
Yes, ma'am.
So that is for lines that are parallel. Parallel lines, lines that slant in the same direction, yes? So before we start writing questions now, we're going to move on. We're going to just describe another set of relationship that can happen between two lines on the Cartesian plane. So let us just sort that out now. So I'm going to just draw back another Cartesian plane. Oh, that was very... All right, great. So let us say you have a line on this Cartesian plane. So I'm going to just draw a line. What's happening? Why you? All right. So I'm going to just draw a line. Let us say we have a line, and this may not be perfect, so please forgive me. I'm going to call this line here AB, right? Let us say we have another line that runs that line not straight. It's meant to be straight, all right? So let's say we have another line called CD that runs like this, right? Now, this is slanted, so you can't appreciate what the relationship between this line is, but I want you to remember what perpendicular line. I don't know if you've ever seen this drawn before. Perpendicular line. So if this was a line called AB and this was CD, you would say CD is perpendicular to AB. You following me? So this is what a perpendicular line looks like, right? This is what you see me draw over here. So if I'm writing a perpendicular line, I don't usually write it out. I just draw this because it's then understood that it's perpendicular. So you have one line that is running opposite to the other, almost to make sort of a 90-degree angle between both lines. That is a perpendicular line. Everybody follow me?
Yes, ma'am.
So that is what we have over here. We have two lines that are running. Now, unlike the example that I showed you just now, they're not touching, right? So when I drew it a while ago to show you what really a perpendicular line is, they were touching, but it doesn't, they were touching like that, but it don't have to touch to run perpendicular, right? This line is perpendicular to this line, just the same, even though it's not touching, they're not touching each other. And so the same is true for lines AB and CD over here. They are perpendicular to each other, right? Because they run opposite in a 90-degree sort of way, right? I don't know what's the best way to say it, right? But visually you get the picture. Do you? Yes,
Yes,
no?
ma'am.
Yes, ma'am.
All right, I just want to know, say, you understand. I'm looking for a proper definition for a perpendicular line for you. Two lines which meet at a right angle. That's what them say. Perpendicular line. Yes. The relationship between two lines which meet at a right angle, blah, blah, blah. So, more of the same. I've been saying it the correct way. So a perpendicular line could look like this. Yes, because they both meet at right angle. A perpendicular line could look like that. Well, that is the same thing. It could look like, this is what I meant to do. It could look like that, could look like that in the middle, or it can look like that at the bottom. You follow me? Right? Whenever perpendicular lines cross each other, you will see it being referred to as a perpendicular bisector, meaning that it cuts the line, it cuts through the line, called a perpendicular bisector. And when you hear perpendicular bisector, now this relationship over here would not be a perpendicular bisector because CD doesn't cut AB or vice versa. But they still are oriented at right angles to each other. So when you hear the word perpendicular bisector, when you're doing geometry, you know that perpendicular refers to the orientation of the lines, meaning that they are at 90 degrees to each other. And the bisector means that it cuts through it, right? Like any of these. And it could be anywhere along the line, it cuts it. It's a perpendicular bisector just as long as it cuts it and forms that 90-degree angle, yeah? Follow me so far?
Yes, ma'am.
So now, let's talk about what the relationship of these, of two perpendicular lines, what relationship of perpendicular lines are. So I'm going to just extend AB to touch CD so that it is correctly represented on the graph, all right? So just put in some space here. So when we were looking at parallel lines, because they sloped in the same direction, and a gradient is a measure of the slope, we could easily say that the gradients were equal. The situation though for perpendicular lines is not that black and white. It's not equal because they don't slope in the same direction. They slope and cut each and they form like a 90-degree angle, right? So the relationship between these two lines now is between their gradients. And I'm going to just write it down first and then we can talk about it a little bit, right? So You can express it in one of two ways. All right. All right. So let's look at this now. Let's go through it. So what we're saying here is that it says the product of the gradient of AB and CD is equal to -1. What that means is that if you should find the gradient of this line AB, so let's say you go through your normal procedure and you do rise, overrun, and you find the gradient of AB, and you do the same thing for CD, and you find your rise overrun for CD. Because they're perpendicular, if you should multiply the gradient you get so I'm going to put it as, I'm going to represent the gradient as M properly as it ought to be represented, yes? So if you should find the gradient of M of, this is what, CD, and over here, so you're going to find the gradient of AB. If you multiply both of these together, the answer should be -1, right? And so that is the relationship, the product of their gradient. If you multiply them gradient together, you're going to get -1. Another way to say the same thing, and we're going to prove that both of these, the first way of expressing it and the second way of expressing it is the exact same thing, is to say that the gradient of one of the line is a negative reciprocal of the other line, right? So if you should find the gradient of, say, CD to be 4, right? Because we know that it is perpendicular, based on this rule, it is saying if you find the gradient of one line, then the gradient of the other line is going to be the negative reciprocal. So we know what negative is. You slap on a negative sign on it, right? The reciprocal is when you invert it, right? So let's not forget that. So for a whole number, we can express, just inverting a whole number like this sitting by itself probably seems odd. But remember, you can express a whole number as a fraction by putting it over 1. So if 4/1 is, and this is just an arbitrary gradient now, if 4/1 is a gradient of CD, then the gradient of AB should be the negative. And I'm going to put the negative sign there, right? It should be the negative reciprocal. So I'm going to flip this now to be 1/4. So then if the gradient of CD is M, because what I'm talking about, if the gradient of CD is 4, because we know that CD and AB are perpendicular, the rule states that the product of their gradient is equal to -1, or we can see the other gradient. If we know one gradient, then the other gradient. To find the other gradient is pretty easy. We just take the negative reciprocal, and that's what we did here. And so -4 would, -1/4, which is a -1/4, would be the gradient of the other one. Everybody follow? Huh?
Yes, miss.
Everybody follow, right? Now, if we should take the same thing, I'm using the same example, right? And I just want to, so we have a perpendicular, two perpendicular lines. I'm just writing it out as a question so we can, I just want to, so we have two perpendicular lines,
One.
AB with a gradient of, I'm just writing shorthand, 4. So the question would ask, what is the gradient of CD? So it worked, that's what already, you know, remember we had said, if the gradient is 4, if the gradient of AB equals to 4, then the gradient of CD would be the negative reciprocal, and 4 is the same as 4 over 1. So we would just flip this and get negative 1 over 4. So the gradient of CD would be 1 over 4. So what I want you to appreciate is if the question had given us that the gradient of CD is negative 1 over 4, would the rule still hold? Let us check that. If we got the gradient for CD to say, okay, that's negative 1 over 4, we can apply the rule just the same. The gradient of AB, so the gradient of AB would then be, let's get another color, the negative reciprocal of what CB is. And remember, this is now a quarter, so we have to flip it, but we have to also remember that that's already negative. So we'll put a negative sign right here. So I will flip it, negative 4 over 1. And these two negative signs here would be a positive. So it would be positive 4 over 1, which is positive 4. Are you seeing that? Yes?
Yes.
So it works either way, right? I just want to be able to prove that to you so you can appreciate and understand what you're doing. I'm not a fan of people just sorting things and then moving right along, right? So let us look now and examine the other way of expressing this rule. The other way of expressing it says that the product of both gradients will be equal to negative 1. So let us check and see if that holds true. We got the gradient of, this is supposed to be a M, of AB. We said that that was 4, right? And we got the gradient of CD to be negative a quarter, and that's because they are perpendicular. So let us see if when we multiply them together, we get negative 1. So let's go. So this is pretty simple. 4 times negative a quarter. So I'm going to just work it as a fraction. So 4 over 1, which is the same as that 4 there, multiplied by negative a quarter. And I'm keeping a negative sign, that's important. So 4 times negative 1 is negative 4. 4 times 1 is 4. 4 and 4 cancel to give you 1. Answer is negative 1. Everybody appreciate that? Yes, no, maybe so?
Yes, ma'am.
All right. So since we are all appreciative now of what happens with our, parallel lines and perpendicular lines, we're going to just, just flex the muscles of our understanding with some questions. I'm going to just write on a question on the board, and then I will work it out and we will work it through together, all right?
Yes, ma'am.
Okay. I'm going to just divide it. It's a two-part question. So just to make sure I have enough space to work each question, I'm just going to divide it into two sections. All right.
Okay.
Just going to divide the paper into two sections, or whatever you want to call it. Why the handwriting beat me up bad on this paper, on this thing here. So A. All right. So let's look at this question here. So it says you need to find the equation of the line which passes through the point 3, 6. So for me personally, I like I am very much a visual learner. You may not be, but I like to always sketch something, right? So just to keep me grounded in terms of what I'm going to do. So we have a point 3, 6. So 3 is on the x-axis, 6 is on the y-axis. So I have a point 3, 6, and we are being asked to find the equation of the line which passes through the point 3, 6. So there is a line that passes through this point 3, 6. Yes?
Yes.
And we're being told that this line is parallel to another line, right? So we have some other imaginary line, for argument's sake, that it is parallel to. So I'm putting that imaginary line in blocked, in what you call this, broken lines, right? So we have this line, which is our line of interest, and we're being asked to find the equation for it. And we're being told that the line that we want to find the equation for is parallel to another line. And we got the equation of the line for this parallel line, right? So this parallel line has, it's what do you call this now? The equation of its line is written in a form 2y minus 8x plus 2 equals 0. But we know that our equation of a line is supposed to be in the form y equals to mx plus c. So we need to rearrange this right here. We need to rearrange it so that it is in the correct format. And by looking at it, you can see, or you should see by looking at it, that you have y is 2y right here. So at least to get y to not be 2y and to be just 1y, you can divide through the equation by 2. So that's what I'm going to do. I'm going to divide this initial equation that we got, 2y minus 8x plus 2 equals to 0. So I'm going to, well, before I do that, I need to carry y across the equal sign because it's equal to 0 now. And I need to have it be equal to y. So I'm going to just rearrange it and have it to be. So when I carry this 2y across the equal sign, you can, there's an imaginary plus sign here. So when I carry it across the equal sign, it's going to become negative 2y. Yes? Everybody agree with that?
Yes, ma'am.
So that's negative 2y equals to minus 8x plus 2, right? And then I can divide through now by negative 2, negative 2, negative 2 to get the equation, the proper equation of the line. So that would be negative 2. That cancels that. So I'm left with y here equals to negative 2 going to negative 8 to give you 4. So you're left with 4x, negative 2 goes into 2 to give you negative 1. So I now have the equation of my imaginary line, right? So the equation of this line here, I don't want to put it in the same color. The equation of this line here is y equals to 4x minus 1. Now, I went through the process of finding the equation of this line, y. May I ask why? No guesses?
Mr. Repeat
Remember?
that, I didn't hear you.
No, not here. May I ask you why? Why I think we had to go through
Okay, I did not hear the question. My internet is going in and out.
Okay. So we went through the process to find this equation of this imaginary line that we don't even get a point for. We only know that it is parallel to our line of interest. Because remember, there is a relationship between the gradients of parallel lines. And we are interested in the equation. Remember the question initially, asked us to, let me just highlight it so that we keep at the front of our minds what we're doing. The question asks us to find the equation of the line that passes through the point 3, 6. So we're trying to find the equation of this line right here. I'm going to highlight it too, right? We're trying to find the equation of that line. So probably one of the first steps to find that equation is finding its gradient. Why? How can we do that? We know that the gradients of parallel lines are the same. They're equal, yes? So if I can identify the gradient of the parallel line, I also can identify the gradient of my line of interest, right? So the gradient of my parallel line is right here, which is 4. So I know that the gradient of my line is 4. Everybody seeing how I get that?
Yes, sir.
Everybody seeing, right? Understand? So I found the equation of this imaginary line because they said our line of interest is parallel to another line, and they gave the equation of that line. From the equation of that line, I found what the gradient is. And because that line is parallel to my line of interest, I now know that the gradient of my line is equal to 4. That's the first step, because to find the gradient of your line, you need to find the equation of your line, you need to find your gradient, and you also need to find your y-intercept. So we found our gradient now. So let me just write back equation of the line, y equals to mx plus c. So we have m, right? We can have a y value and an x value from up here. So we have y value, we have x value, because we're told the coordinate of one of the line it passes through. So then we can go ahead and find c. Agreed?
Yes, sir.
Great. So let's look. Y, remember that this is our x value and that's our y value. So y is 6 equals to m. We just found m to be 4 times x, which is 3, plus c. 6 equals to 12 plus c. 6 minus 12 equals to c. So you have negative 6 equals to c. So there we have it. We now have our c. So we can then now write out the equation of our line of interest. The equation of our line of interest is going to be y equals to 4x minus 6. Should be plus c, but because our answer is negative 6, 4x minus 6. That's the equation of our line of interest. So this line right here, so is 4x minus 6. So I want you to appreciate now that for these two lines that are what you call it, parallel, you can see that they have the same in the equation of their lines, their gradients are the same, but their y-intercepts are different. So they don't have the same equation of the line. They just share a gradient because they are parallel. Clear?
Okay.
Questions on this part of the question? Kind of sound funny, but yeah. Any questions on this part of the question? All right. All right, not yet. So I'm going to just erase this section so I have space to work out part B. All right, so part B says, again, we're using the same major question. You find the equation of the line that passes through the point xy, 0.36. So I can draw back my thing. I have a point here, 3,6. I have a line that passes through it. And I'm trying to find the equation of the line. But this time, my line that passes through 0.36, it is perpendicular to another line, right? So it is, I'm going to draw that imaginary line now that it is perpendicular to. It's perpendicular to another line, drawing that perpendicular line in broken line. And the equation of that perpendicular line is y equals to 3x plus 2. So we have the equation of the perpendicular of the line to which our line of interest is perpendicular. So we can work out our gradient. Remember, we're finding the equation of the line. And to find the equation of the line, we need to find our gradient and our y-intercept. So let's start with our gradient. Now, we know that for perpendicular lines, you can work it out 2 ways. So you can first say, if you go back here, I'm going to work it out both ways to show you. One way is easier, but it's always good to know 2 ways in case you meet upon challenges in an exam setting, right? So the first way for a perpendicular line, the first way we can express the relationship between perpendicular lines is to say that the product of the gradient well, the product of their gradients will be equal to -1, right? So I can just express that. Product of, I'm going to call this AB, just because, and I'm going to call this CD. And I'm just arbitrarily calling them that. So I am going to be saying that the gradient of AB, so the gradient, which is M of AB, so if we now multiply the gradient of AB and the gradient of CD, you should get -1. That's what the rule says, right? Yes, so the rule says we know the gradient of CD, so we don't know the gradient of AB. That's what we're trying to find. Excuse me. But we know the gradient of CD. We know that from here. See here? That 3 is our gradient. Everybody agree? So we know that that gradient is 3. What is this? So we know that when we multiply them, you should get -1. So now all we need to do is to work this out, because this is this is an equation. So now if this is being multiplied by 3, to get rid of it, on this side, we need to divide by 3 on both sides. So we're dividing by 3 here, and we're dividing by 3 here. This 3 cancels that 3, and the gradient of AB is found to be -1/3. Understand that? That's one way you can use that first expression of the relationship to get that. Now, the other way that I'm going to show you, which is the easier way, is the gradient of one of the line is the negative reciprocal of the next. Yes. And I truly don't like saying one way is easier than another, because it really depends on each individual, which is why I like working it both ways, and then a person can decide for themselves what they prefer. But I always advocate for knowing both ways, even if you have a preference, because you don't know what will happen or what can happen when you turn up into exam. So let's use it the other way. It says the gradient of one is a negative reciprocal of the other. So we have the gradient of 1 to be 3. So we know that the gradient of CD is 3. And so therefore the gradient of AB is going to be the negative. So I put on my negative sign reciprocal. So this 3 is the same as 3 over 1. So I'm going to flip it, negative reciprocal, 1 over 3. All right? And so that's my answer, 1 over 3. You get 1 over 3 either way. Yes? Following, everybody?
Okay.
So we know that our gradient is negative 1 over 3. All right? The gradient for AB is negative 1 over 3. So I'm just going to write it here. So that's negative 1 over 3. We're finding the equation of the line. So we find M already. So we're just going to find C. And we know X and Y for this line. We know one X value and one Y value to be 3 and 6. So we can then substitute it in the equation of the line and move on from there. So Y equals, Y equals to MX plus C. Y in our case is 6. M we found to be negative a third. X is 3. Let's put that in bracket beside it. Plus C. So I'm just going to just work out this portion here. And I like doing things a little long way just to make sure that everybody's getting it. Negative 1 over 3 times 3 over 1. Negative 1 times 3 is negative 3. 3 times 1 is 3. So that's going to be negative 1 because that cancels that, right? So this equals to 1. So I will have 6. This is a negative 1. So when I carry it across the equal sign, it becomes a positive 1, yes? Equals to C. 7 equals to C. So the equation of this line is going to be Y equals to M is negative a third X plus 7. Follow?
Yes,
Any question? I want to sound so hungry tonight like me.
tired.
I'm tired too. So we're laboring together. What your understanding do?
Yes, miss.
I'm tired too. So we are tired of what we have to labor nonetheless, yes?
True.
That's that. We just have to get it done because exam coming up. So we have to just put in the work. All right. So let's go now to just trying another question. So all we're going to be doing up until 9 o'clock is just working questions so you can understand this, how we use this in questions, all right? So what is the equation of a line which is all right, so that's our question. So we're being asked again to find the equation of a line, and that line passes through point 0.06, right? So we got two pieces of information about this line, about this particular line. The first piece of information we got was that this line is perpendicular to another line, which has the equation y equals 3x minus 2, and we got that it is negative, the point, it passes through a point 0 and 6. So again, I like to start by drawing a little thing so I can, visualize it. That not so straight, but that is fine. So it passes through 0, 6. So let us say that. So 0 on the x-axis, 6 on the y-axis. So whatever the line is, it passes through this point right here. So, all right. So we are told two things about this line. One, that this is 0, 6. So we have we can see off the bat, we have an X information and an information for X value and a Y value for that. And we are told that this line is perpendicular to another line. I'm just going to draw that line in broken line. So it's perpendicular to another line. And bear in mind, you know, this perpendicular line could have been anywhere across you. So just me, I draw it on the bottom, yes, all right? So it's perpendicular to another line, and we know the equation of this line to be y equals to 3x minus 2. So we have an x value, have a y value, and we can find our gradient, because again, like I like to stress, when you are asked for an equation of a line, most likely you need to find the x value and your c value. And if you're given any of these, you can easily substitute them, you know, in an equation, right? So we're going to start off by finding our x value, our m value, which is our gradient. So our gradient in this case, we know that these two lines are perpendicular. So we know that the product of these gradients are going to be equal to -1. So this time I'm just going to use one way of working it. You can choose to use the other way, which is inverting and taking the negative reciprocal. I'm just going to use a product way. So I'm going to call this this line AB as usual, AB, and call this one C and D. So the gradient of AB multiplied by the gradient of CD should be equal to -1. And we know that because we are told that it's perpendicular, they're perpendicular lines. So I don't know the gradient of AB, that's what I'm trying to find. But I know the gradient of CD to be X, to be 3, sorry, because I have the equation of their line. So I can put my 3 there, that's -1. So then I can divide each side by 3. And this 3 cancels that 3. So gradient of AB is equal to -1/3. All right. So I have found my gradient to be -1/3. All right. Clear so far? C now. I'm going to find C by substituting my gradient in the equation of the lines. I'm just going to erase this just to have some space. So to find C, I'm going to just write out the equation for any line, y equal mx plus c. If I'm applying it to this particular line now, I have some information. X, well, y is 6. I don't know why I keep talking about x. M, we found to be -1/3. So I can put -1/3 multiplied by x, which our x is 0 in this case, plus c. Usually I would work this out, but anything times a 0 is 0. So x is equal to 0 plus c. 6 is equal to c, right? So we found our c to be 6, which means that the equation of line AB is, so the equation of line AB, which is the line that passes through 0, 3, is y is equal to -1/3 x plus 6. Good? Questions? No questions?
No, miss.
All right, so I'm just going to work 2 more like this, and then we can call it a night. All right, so let's go again. That was what we did, a perpendicular line. Ew. So I have to write it. All right, so let's write. I'm just going to write down both of the last questions and then I work up both of them. All right, so that's one. All right, so we need to write a little later. All right, I'll just testing out that to see if it can work, but maybe no, it's not the time. All right, so this is our second question. All right, so those are going to be our two questions for our last two questions for the evening. No, what's happening? Can it happen? Yay! This one look a little better. Where did it go wrong now? I equal, oh, this is supposed to be 2x. Oh, all right. So you have to stick with my handwriting for now. All right. Everybody's awake? Everybody asleep? Okay. All right.
Not sleep.
All right. So let's get going on our last two questions. All right. So similar to the ones that we've done before, and I'm giving you these questions just to practice and to get familiar with the concept, all right? This one says, determine the equation of the line which passes the line which is parallel to the line. So we're determining the equation of a line, right? And we got some information about this line. We know that it passes, we know that it is parallel to another line, for which we have the equation. and it passes through a coordinate 7 and 4. So I'm just going to attempt to put that on the thingy. And we know that our line passes through that line, right? 7 and 4. And it's also parallel to another line. And that line has an equation of y equals to 3x plus 2, all right? So we're finding the equation of the line, so we need to find m and we need to find c. So since both lines are parallel, what will happen to their gradients? Huh?
They have the same gradient.
The gradients are going to be the same. Their gradients are equal. So we know that the m, I'm going to call my line here AB. We know that the gradient for AB is going to be the same as the gradient for this line, which is 3. So then I can go ahead, substitute into the equation of the line, which is y equals to mx plus c, because I now want to find c. And we had an x value here and a y value because we were told that it passes through the coordinates 7 and 4. So y is 4, m we know to be 3, x we know to be 7 plus c. 7 times 3 is 21. 4 minus 21 equals to c. That work out to be what now? That look like 17. Is that minus 17? You can tell me. Looks like it. So c is negative 17. And so we can now write the equation of that line to be y is equal to m, we know to be 3, x plus c, which is minus 17, which means our equation is y equals to 3x minus 17. Good for that one? Yes, no?
Yes, miss.
Last question for the night now. So again, we have a line that we're being asked to find the equation for. We know it passes through a point, 4, 1, and it's also perpendicular to a line, another line that has that equation. So I'm just going to go ahead, draw the coordinates for this line. We know it passes through 4, 1. So 4 on the x-axis, 1 on the y-axis. Somewhere like that. The line passes through it, right? And we know there's another line that is perpendicular to it. So somewhere along the line, it is cut by another line. And this line have an equation that is 2y equals to 2x minus 1. So we're being asked to find the equation of this line, right? This one here, for which we know the point. Let me just put this point in. So this point is 4, 1. So let's go ahead now and try to find our equation of the line. So to find our equation of the line, as usual, we need a m value and we need a c value. We need a gradient and a y-intercept. We can find our gradient because we know that there is a relationship with the gradients of lines that are perpendicular. So if I'm calling, as I'm going to call this line of our line of interest to be AB, and the other line to be CD, I can say then that the gradient of AB multiplied by the gradient of a CD should give me -1. Gradient of AB, I don't know, but I do know the gradient of CD, which is here, that's 2. Multiply that, they should give me -1. So I'm solving for AB, just divided by 2. 2 cancels that. So the gradient of AB is equal to negative a half. Yes? So I now have my gradient. I can try and substitute this gradient now into my equation of the line. I'm just going to try and spinach it up. Y equals to mx plus c. I have a y value, which is here. No, that's not true. This is my x value, and that's my y value. So y is 1. M I found to be negative a half. X is 4. And plus c. So I need to work out this part first. I'm just going to work it out over here for you. Put in a different color for you. Negative 1 over 2 times 4 over 1 equals negative 1 times 4 equals to negative 4 over 2 times 1 is 2. 2 into 2 goes 1 times. 2 into negative 4 goes negative 2 times. So here we have 1 equals to negative 2. Everybody following?
Okay.
Plus c. So then I'm going to carry this c, this negative 2 over the equal sign to solve for c, which is 1 plus 2 equals to c, 3 equals to c. So the equation of this line, because I now have c and I have m, equation of this line is going to be y equals to m was found to be negative a half x plus 3, which is c. Clear? Shauna look like she dropped off. All right, so are you clear, Carrie Ann? Carrie Ann gonna sleep too? Carrie Ann. Ah, what is that?